Okay. So as I said, the name of the webinar is Rethinking IoT with Distributed Systems. And I'll start with a brief introduction about myself. I'm a senior software developer at Wallmart Labs. I graduated from IIT Dhanbad in 2015. I did my BTech in computer science and engineering. And then I did my master's in computer science from Texas A&M University. And since then, I'm working at Walmart. So it's been around 3 years now. And then I've worked, so inside Walmart, I've worked on Walmart Cloud Platform Services. And then currently I'm part of Global Infrastructure and Engineering Organization. And my area of expertise include distributed systems like Cassandra, Solar, Spark, Kafka, Elasticsearch. And then apart from this, I've worked on front-end services, back-end services, and currently I'm involved in data analytics as well. So that's something about myself. And now let's get started with IoT. So the technical definition of IoT could be said as the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. So the first time I read this definition, I was like, what is this? I can't understand what's IoT. So I think the confusion arises not because the concept is so narrow and tightly defined, but rather because it's so broad and so loosely defined that it can get hard to nail down the concept in your head when there's so much examples and so many possibilities with IoT. So I'll present a simple and a non-technical definition to you guys. So simply said, IoT is actually a concept that means taking all the things in world and connecting them to internet. So so imagine any device, and if you connect that device to internet, that becomes part of IoT infrastructure and part of IoT ecosystem. So it can be anything that connects to internet. So why IoT matters? So why are we learning about IoT, and why are we so concerned about IoT? So it makes your devices smarter. So when something is connected to internet, that means that it can send or receive information, or can do both. And this ability to send or receive information makes things smart, and being smart is good, right? And when we go back in time, when we had like a simple devices, simple cell phones. So those were the times when making a device smarter compelled to have like a storage or a computing power inside the device itself. But with the concept of IoT, these requirements are detached from the device, and um, now the device just needs to be connected to internet, and at the back of it, it can have like a storage and a supercomputer that is the brains of the entire ecosystem. So we are making devices smarter by connecting it to internet, but at the same time making the device itself dumb. So it can get a little confusing there. So we are making the device itself dumb by removing all the computing and storage, but we are connecting it to internet and making it smarter that way. And then, so when we interconnect devices, so those devices can learn from each other. Now, since uh, Yeah, since the computing is detached from the device itself, therefore it means that there is a super brain that is receiving all the data and that is learning from it. So this creates an ecosystem where one device can learn from another device, which can be like potentially miles or even geographically away from each other. So now let's talk about cost reduction for manufacturers and for customers. How this IoT concept is helping manufacturers to reduce the cost, and then that in turn reduces the cost for the customers. So since the device itself is very dumb now, all it needs is just an internet connection, and does not need any complex storage or any complex computing power. So that means that that reduces the manufacturing cost of it, and that also like streamlines the manufacturing process. And fast development and feature rollouts. uh, so now, since the devices are dumb it's in itself, and the features that needs to be developed are not being pushed to the device itself, therefore the features sorry, the development process becomes faster and more productive, and the features get rolled out to not to the devices but to the cloud or to the brains of the Internet of Things. Now all these things are creating like endless possibilities in this domain, and let's jump excuse me, let's jump into those possibilities and see what's going on with IoT world and IoT domain. So I'm going to like demonstrate few applications of IoT and how IoT is helping in different domains. So let's start with IoT in healthcare. So we all are familiar with smart watches, smart devices that we wear, smart wearables uh, that wirelessly connect with internet and can help us monitor our blood pressure, heart rate, and glucometer and all that stuff for us. So I think this is one of the great areas where IoT is helping to monitor your personal health, and it is helping the doctors as well to monitor the health while sitting like miles apart. I think there's like in near future you can even have some kind of prediction if there's going to be a heart attack or not. So all these things are being possible just because of IoT. Uh, the other thing where sorry the other domain where IoT is shining is building smart cities. So um, nowadays cities are having traffic cameras, speed traps, they have motion sensors and different things to like find solutions for traffic congestion and for public safety. And then there are like solar lights available, there are solar uh, other things that are helping cities to have energy conservation and like go ahead with a green revolution. And then talking about agriculture, IoT solutions are focused on helping farmers to close the supply demand gap by ensuring high yields, profitability, and protection of the environment. So like imagine a scenario where a smart irrigation system is being installed in fields, and that smart irrigation system is connected to internet, and it can irrigate the fields depending on like how's the weather prediction. So if the weather is like dry and sunny, then it can irrigate the fields more, and if the weather is going to be rainy and it's humid and rainy, then it can adjust accordingly and then irrigate the fields in that manner. Uh, So at the same time, we can have like livestock tracking and geofencing, where you can have like small badges on top of your cattle's, and you can track where they're going, and you can build like an artificial geofencing, so that whenever they cross that artificial geofence, you get an alert saying that, okay, you're not, now your cattle is maybe moving to some other field, or maybe out of your reach. So those are things where IoT is helping in agriculture. Now talking about industrial automation. So we all like have seen videos where inside an industrial plant there are robots working, and different sensors are installed that can do a quality control, that can check the quality, whether it can be a bakery where there are sensors installed to see the temperatures are correct, or it can be iPhone factory where it sees the dimensions are correct and everything. So the robots and the sensors are really helping in controlling the quality of a product and inventory management. So for this, I have like a great example about Walmart. So Walmart has these robots installed in their stores, which go around aisles and see if a particular item is going out of stock, and if the item is going out of stock, then it can alert and say that it can maybe order more items, and it can alert an employee to restock those items in the shelves. So yeah, Walmart is already doing inventory management through robots, and a robot is again a device that is connected to internet, so it covers the IoT domain. And then since there's so many machines and sensors installed, so it helps the industries to cut down the cost and make them labor efficient, because now you don't need so many people doing so many work for you. Things can be streamlined, things can be taken, um, uh, like sensors can do work, robots can do work for you that like maybe required more labor power. Disaster management. So this is something I really, so this is one domain that I really like personally, because I've seen live examples for this domain. Now, like as the slide says, that IoT devices and technology is helping in disaster risk minimization, prevention, emergency response, and disaster recovery. So let's talk about the risk minimization first. So when I first came to US, I saw you get notifications, push notifications on your cell phones if it's going to be if there's a high chance of flood near your area, or if there's a storm coming in, then you start getting push notifications. So that is something that is minimizing the disaster risk and preventing lives, saving lives. And then we have sensors installed to check to check global temperatures, to check how's our ozone layer doing, and similarly, what is the rate of ice melting on the glaciers. So all these sensors are working together to um, minimize the risk of disasters and minimize to help replenish uh, our earth. And at the same time, for emergency responses, we use our mobile phones to call emergency systems like police or health services. So those things are again IoT. And then for disaster recovery, there are drones that helps you down to see what is the impact area, and then there are robots that help. Um, so there was an interesting project in my university, or like the Texas A&M University. So there was a professor that was working on disaster management, disaster recovery robots. So those robots are designed to go inside the rubbles and see if there's someone alive inside the rubbles, and then send notification that, okay, there's someone inside living and breathing there, and maybe need some emergency, in need of an emergency. So those are the areas where, okay, so those are the areas where IoT is really shining and making our lives easier. So since I've been here for some time, and I've seen how like the systems are being influenced by this IoT culture and IoT domain. So I wanted to I wanted to showcase this in my presentation, that how IoT is actually influencing those architectures, and what are the things that are actually influencing those architecture systems and design of those architecture systems. So first component is scalability. Um, Scale for an IoT system applies in terms of the number of sensors connected to the system, in terms of network which connects them together, in terms of the amount of data associated with the systems and its speed of movement, and also in terms of the amount of processing power required. So all these things need to be scaled so that you can accommodate more IoT devices. Um, for an example, like if you have like thousands of um, say weather monitoring um, devices, now in order to like send the data from them and then have them intercommunicate, you need a scalable network. And then since those um, devices would be generating data, so you need so there will be a good amount of data. You need some systems that are scalable in terms of data. And then at the same time, if you need to do some data analytics, then you need systems that have so much processing power that can work on such a huge data and do some kind of analytics. So yeah, scalability is one of the key factors that are influencing the architecture of systems that are being designed currently and that will be designed in future. Now, the another aspect is big data. Since the scale of IoT devices is so vast that it is generating like terabytes of data every day, and not even terabytes, I would say petabytes of data every day if I include like all the devices across the globe. Then so IoT systems are thus like the classical examples of big data processing. Now cloud computing is another important area where IoT is influencing a lot. So IoT systems frequently involve the use of cloud computing platforms, because cloud computing platforms offer a potential use of large amount of resources, storage, data, and processing powers that you can leverage whenever you require it. So it is like a solution in itself. So IoT is really influencing um cloud computing and cloud architecture. Real time. Now, IoT systems often function in real time, and they need to process events in real time and then generate responses for that events. So there's a very good example that I want to share with you guys on the real time. Actually, two great examples for the real time. So if you have heard of Google Nest, so it's like a smart um, smart system that you can install at your home that can maintain the temperature for you. So that is a really good example of real-time analytics. If so, it controls the temperature automatically depending on what's the current temperature inside your house, how's the temperature outside, and so that is doing a real-time analytics. And another example is comes from Uber. And I know it's not in India yet, but it's here in US. So Uber has a system where it can detect that if a driver has called the customer, and then immediately after that call, if he like cancels his ride, then it creates an alert in the Uber system, and they get to know about it. So that is a really good example of real-time analytics. Um, and then highly distributed. Yep. So since IoT systems span across can span across buildings and maybe cities or even the entire globe, so having systems with such a large span include architectures like backend architectures where you send your data to be equally highly distributed, and to um, to control what's going on in the front, right? So some backend things has to be equally highly distributed. Then security and privacy. This is another important worth mentioning topic. Um, Sorry. So the IoT systems and IoT domain needs a really good security and privacy. And so the backend services, the backend systems that are supporting Internet of Things has to be equally secure and have privacy rules running on them. Okay, let's talk about distributed systems. So a distributed system in its most simplest definition is a group of computers working together as to appear a single computer to the end user. So what this essentially means is that you can have a system like in this like in the picture here, you can have like 3 or more computers or um, servers working together, but for a device, for a IoT device, these would be one entity. This can be like one database that has multiple nodes or multiple servers together, like tied together, and then so yeah, basically many nodes and one distributed system. That's the basic idea of distributed system. Properties of distributed systems. So distributed systems provide high availability. So this is like very um, um, as you say, common sense kind of a thing, that if you have multiple nodes that are working together and in a highly distributed fashion, so if there can be hardware failures, there can be other failures, network failures as well. So if there's a failure on one node or two nodes, then the entire system doesn't crash. But on the contrary, if you see like a centralized system, then everything is on one server, on one piece of hardware, and if that piece of hardware goes down, uh, has any failure, any kind of failure, then the entire system goes down. So like introducing high number of nodes introduces more tolerance to failure, and that's why your system becomes more available, and yeah, basically it becomes more available. Horizontal scalability. So now imagine like you have a backend system where there are 10 servers running together, and you have like 10,000 Internet of Things devices that are installed maybe at someone's home. Now if you want to like increase those devices from 10,000 to 20,000, so at the same time you need to increase the capacity of your distributed systems that are working behind the scenes. So horizontal scalability is really important. So in these scenarios, like in a distributed system ecosystem, you can simply uh, increase the number of machines to increase the resources, and that can cater to more devices. Heterogeneity. Okay, so another good feature that comes in with the distributed systems is like all your different nodes that comprises of a distributed system doesn't have to be of the same type, doesn't have to be of the same, doesn't have to run same operating system, don't have to be in the same network bandwidth, and hardware can be different. They can have different programming languages running on it, and they can be implemented by different developers, and then um, so the entire ecosystem can be very heterogeneous and can still work together to as an entity. That is like one of the key properties of a distributed system. Now, resource sharing. So if you have like multiple nodes working together to achieve a common goal, then if so there are multiple nodes, so there'll be like more resources, and since there are more resources, so it can like it can help in resource sharing, and then suppose there's a service running on uh, one server, and then suddenly there's some crunch in some memory crunch or something that inhibits to run that service in that particular server. So it can go to any other, the service can go to any other server and start running there, because all these servers are a part of one distributed system, and they're part of one resource group. So it enables resource sharing as well. Okay, why distributed systems is required for IoT? So why do we need distributed systems to handle IoT devices and handle the IoT domain? So the devices can be present in, like, these are some examples that I found from my experience, and there can be more reasons for why choosing a distributed systems. But let's go over these and see how these fit in together. So the devices can be present in different geographical regions. Therefore, getting data to a centralized system will be costly, and therefore data is needs to be distributed across regions. So this comes from experience that Walmart has stores in all the geographical regions, whether it could be US, Canada, Mexico, Japan, Europe, China, and many more countries. So each of these countries generate their own data because there are devices installed in each of these countries. Now imagine a scenario where you have to uh, uh, get data from maybe China to US, because if we don't go with a distributed system, if we go with a centralized system, now imagine a very huge server somewhere in US, and the data needs to come from Canada, Mexico, Japan, Europe, China, everywhere. Now the data is coming from everywhere to a centralized system. That increases the cost because the data has to come through multiple hops, through multiple data carriers, and through multiple regions, so to finally end up into one particular server. So that introduces cost as well as latency to ship the data from different geographical regions to a central region. But if you have a distributed system, now suppose let's go away from a centralized system, let's go towards a distributed system. Imagine you're using maybe Google Cloud or Microsoft Azure Cloud. So they have uh, like compute regions in across the globe. So you can easily send data from, say, China to the nearest computing zone or to the nearest computing region, that would decrease the cost, and that would again like have your data distributed across multiple regions. That is like one major reason why we need distributed systems. Now, centralized systems cannot handle the amount of data generated by devices. This is again very common sense, because you can have like a set of few servers, maybe one server or two server, but those servers cannot produce that much processing power to um, to handle the data coming in. So to give an example, like currently I'm working on IoT inside Walmart, and we get around terabytes of data every day from like plethora of devices installed across the globe, from US, Canada, Mexico, Japan, Europe, China, everywhere. And if we have like a centralized system, then those centralized system can easily get overwhelmed and can easily crash. So that's why we need distributed systems. And the last one being that the centralized systems fall short when it comes to real-time processing and analysis of data. So yeah, because centralized system cannot analyze so much data in real time and cannot do any sort of analytics. For doing analytics on terabytes of data, you need again need a distributed system. So distributed system is basically key for IoT, and I think IoT will keep influencing how distributed systems are getting designed, and vice versa, like how distributed systems, if we have like good distributed systems across the entire chain, then we can have like more number of IoT devices. So the last topic to cover would be future of IoT. So if we see that the Internet of Things, the devices such as machines, sensors, are expected to generate like 79 zettabytes of data by 2015. And this prediction comes from IDC, that is like International Data Corporation. And so the projected annual growth rate of IoT devices is around 28.7. So you can imagine how this field is going to grow by 2025. That is like next 5 years. And then IoT fuels artificial intelligence and machine learning. So as I said that uh, IoT is generating so much data, and so much data needs to be transferred over the network and then stored somewhere, and then needs to be analyzed. So uh, there are organizations that are clueless on how to manage this amount of data, and no organization will ignore this data if it is related to customers and their personal information, because in today's world, data is money. And if you have this much data about customer and their personal information, then there's like no limit to what you can do with that amount of data. So IoT allows data flows between so IoT allows data flow between the devices, and AI can help to manage this data without any human errors. So that's where artificial intelligence and machine learning will shine in future to help Internet of Things and to store the amount of data it has. Another thing is 5G, and 5G is fueling IoT needs, and it might become like a backbone of Internet of Things. And it is really important that the transformation from 4G to 5G comes really soon, and because it's really helpful for the growth of IoT. So today's 4G networks can support up to 5,000 to 6,000 IoT devices on a single cell. But the 5G network can scale up to like million device and can handle up to like a million device in a single cell. So you can see like how much times this increases and how much scope it gives for IoT devices to like uh, grow. So yeah, I'm open for any questions. And
So we have few questions. Hello, am I audible?
yeah,
So one question from Dev Donapati. What are the gateways used in IoT?
gateways as in, can you please elaborate?
So, Mr. Dev, can you please chat? Yes. How IoT, ML, and GPU can be related?
How IoT, ML, and GPU can be related. Okay, so as I said, that machine learning can help in uh, like transforming the data, intelligently transforming the data from one device to another device, and then can have analytics going on, and can without any kind of human interaction in between. So machine learning has great uh, uh, great things to do in this field, I would say. And it still has a lot of potential because it's not being used entirely, and I would say it is not being used to its full uh, potential. And then again, if you see GPUs, then GPUs can increase the processing powers and can increase how fast the data can be processed. So these are like tightly correlated with IoT.
Okay, so we have another question. As a senior software developer working with Walmart Labs, what were the practical difficulties you faced while implementing?
So I would say scalability is one of our most difficult things that we face every day. So imagine that we have around 6,000 stores in US, and then around 500 distribution centers, and each I'm just trying to give you a perspective of our scale. So each store has multiple access points from which you can connect to internet, right? And then each store has different kinds of IoT devices, whether it be robots, whether it be switches, routers, and whether it be handheld devices that employees use for scanning, for inventory management and all those stuffs. And then each store again has like registers. So I would say each store can have around 1,000 devices, and then we have like thousands of stores across internationally. So that generates like terabytes of data for us every day. So scaling our systems to that level is always challenging for us. So that's something that we deal every day.
Thank you. We have another question. In
Mhm.
case of distributed system, how load balancing could be taken care of?
So yeah, load balancing is really important in distributed systems, because if you don't have like a good load balancers and good load balancing techniques, then you can have like hotspots. So imagine like there are 10 servers running together, and now you're sending all your requests to only one or two servers, then those one or two servers will be overwhelmed. They'll have like high CPUs, high memory, high JVM inside, and others might be just sitting idle because there are no requests coming to those 5 6 servers. So yeah, I would say that load balancing is really important to distributed systems.
Can I ask another question? Hello, am I
Yeah.
audible? Yeah,
Yes, yes.
we have another question. Um, how can IoT be used in healthcare?
Healthcare. Okay. So as I said, like in my slide, that you have different wearables, smart wearables in industry, whether it be Fitbit, whether it be Apple Watch, whether it be any other wearable. So that is one example of IoT helping in healthcare. It helps you monitor your heart rate and how much calories you're burning and all those steps, how many steps you're taking. And apart from that, nowadays you have like smart, what do you call those? Diabetes sensors that can like get the insulin level of your blood and get the how many what's your current diabetic uh, value or whatever that is called. And then you have smart thermometers. Right now you have smart um, blood pressure machines, and not just that. So those are some things that are for like the patient, but I would say IoT is also helping hospitals and doctors in multiple ways. So you can connect with your doctor currently in coronavirus and COVID situation. We don't have to, like in US, we don't have to visit our doctors if we have something like a mild um, any mild infection or anything else. You can just set up a meeting with your doctor like through your uh, through internet. So those are also like Internet of Things. So these are like very basic things that we always tend to forget, and we think that these are not covered under IoT domain. But as I said, that anything that is connected to internet uh, falls under IoT domain. So yeah, IoT is helping healthcare providers and in healthcare industry a lot.
Okay, so we have another question. What types of sensors are applicable?
What kind of
Sensor,
are applicable?
yes.
Sorry, I didn't get this question.
Um Saswati Maitri, can you please explain what are you trying to ask? Let's move on to another question till then.
Mhm.
Which machine learning algorithms support maximum for IoT?
There's no one particular machine learning algorithm that like fits all your needs. So it can be anything. It can be like a simple uh, neural network that can work for you, or it can be complex uh, any other algorithm that can. So there's no like one algorithm fits all kind of approach. You can have an NLP, natural language processing algorithm, or um, like it really depends on your use case what you want to solve.
Okay. Can I move on to another question?
Mhm.
If I'm connecting washing machine to internet, what are the computing needed for washing machine?
So I really don't know what what are you trying to ask. So if you connect your washing machine to internet, first it should be like um, it should be supported from your manufacturer that you can connect your machine to internet. And then again, if your manufacturer supports that, you don't need any kind of computer or any hardware to support that. It will be taken care by the manufacturer, not from you.
Another question. Mm, just a moment.
Yeah.
Is there any impact on latency if IoT devices increased in cloud?
Yes. So latency is highly driven by bandwidth, and if you have like a lot of devices connecting to a single cloud or maybe a single region, then it can really impact your latency, because all your data would be going to just one cloud, one region, and behind the scenes it can go to just one database. So that database might get overwhelmed and uh, uh, might just get slow. So yeah, at the end result would be that it would increase the latency. So you need, so as I said, like you need to simultaneously scale your backend services and your backend systems as you scale your number of devices.
Is IoT applied to electrical engineering problems? Are IoT, machine learning, big data analytics interrelated?
So for the first part of the question, yes. But if you like ask a very specific example, um, electronics, he said electronics engineering, right? Yeah, so there's smart sensors right now that can uh, send this, what do you call it, radio frequencies and that stuff. So I'm not able to like particularly give you a correct example maybe, but yeah, IoT is kind of a field which you can apply to any engineering and can scale to any level. And then the second question was, is IoT and machine learning
Machine
related?
learning, is IoT, machine learning, big data analytics interrelated?
Yes, yes, it is interrelated. Like they are not, uh, like it's not like you need one to solve. Like it's not like you definitely not need machine learning if you have IoT, but you might get a use case where you want to have machine learning and you want to have big data analytics on top of the devices and on top of the data that you're gathering. So it's not like you would need all three at the same time, but those three are like a good combination to use.
Okay. So somebody's asking, can you share a resource from where we can learn IoT from the scratch?
Hmm. Okay, so I'll do some research on this because on top of my head, I don't remember anything. So I'll do some research and I'll probably send this to Disha or Rahul, and you guys can circle back with them.
Okay. How can IoT help in banking sector?
In which sector?
Banking sector.
Banking sector. Okay, this is good, and this is already helping in banking sector because you have your online portals, you have your like you get messages on your cell phone about your balance, or you have internet banking, even your ATMs. Those machines are uh, kind of internet of things because those are connected to internet servers, and as soon as you withdraw money from them, it gets deducted from your account. So it's already helping the banking sector.
Another question, what impacts will the Internet of Things have on infrastructure and smart cities sector?
So smart cities, uh, it can help you to like solve the problem of traffic congestion. This was again from my slide. Uh, it can help you solve the problem of public health, public safety, and then um, it can help you to conserve energy. That's again like uh, that again comes under the smart city domain. Um, so yeah, it has a lot of potential there.
Okay, thank you. Another question: how IoT help to generate generation of electrical energy?
Uh, IoT helping to generate electrical energy. Okay, so one example on top of my head is windmills. So those are again nowadays connected to internet. Those again, they change the direction of their blade depending on from where the uh, wind is flowing, and then the similar way there are smart solar panels uh, that help in again generating the electricity. So those are the two areas that I know of, but there can be more areas.
Is it possible to manage the zettabytes data generated by IoT on 4G?
Is it what possible?
Is it possible to manage the zettabytes data generated by IoT on 4G?
Yeah, currently everything is on 4G, so we are already generating zettabytes of data around the globe. So yeah, it is possible. It is just easier to manage that on 5G, and it is easier to scale it up if we have a 5G connection. But yeah, it is possible to handle with 4G as well.
So we have the elaboration on the sensor thing. In smart agriculture, what kind of sensors are used?
I'm not sure. Sorry.
Okay, let's move on to another question. What is a thing in the context of IoT?
What is?
Thing. Like in IoT, what is
Okay,
the thing?
okay. So in very lame words, thing can be anything. So anything that is connected to internet is the thing.
Okay. Can we use IoT in transmission and distribution of electrical power?
Mm, I think we can, but I don't have any examples. But yeah,
That is it. Like any more questions you can ask in the chat box. I think that is pretty much it. There are
mhm.
no more questions coming. Thank you for your valuable time, sir. Thank you for enlightening all of us on this topic. Guys, let's show some reactions to sir for giving his time. There is a reaction tab available on your screen.
Thank you, everyone. The good reactions coming in.
Thank you for being such a lovely audience.